Limits Part 4, Indeterminate Forms number 2. We're going to look at limits that give us infinity over infinity. So last time we saw that when we plugged in a limit we got 0 over 0. That was a clue that there was some algebra to do. That is the same case here when we get infinity over infinity. Let's look at a few really simple examples. What if we have the limit as x goes to infinity of x squared over x? If I were to plug in directly, we would get infinity over infinity. But of course, we can see that the expression can be simplified to simply x. And then if we plug in x goes to infinity, we of course get infinity. What if we did something similar? Limit as x goes to infinity, but we have x over x squared. Again, a direct plug-in gives us infinity over infinity, but we see that we can simplify the expression first, giving us the limit as x goes to infinity of 1 over x. And then when we plug in infinity, we get a number that is really, really, really close to 0. One more basic example. Let's do the limit as x goes to infinity of, say, 3x squared over 4x squared. A direct plug-in gives us infinity over infinity, but we can simplify top and bottom a little bit, giving us 3 over 4, and we don't have any x's left over, so we know that the limit is 3 over 4. We're going to take that idea when we do more complicated looking problems. I want to show you one of these complicated looking problems the long proper way, but then afterwards we're going to use a shortcut that hopefully we will see while we do this problem. So let's look at the limit as x goes to infinity of 2x squared plus 4x minus 1 over 3x squared plus 6x plus 2. The official way to do a problem like this is to factor the highest power out of the top and bottom as such. So if I take an x squared out of the top, we're left with 2 plus 4 over x minus 1 over x squared. And if we factor the highest power out of the bottom, which is also x squared, we end up with 3 plus 6 over x plus 2 over x squared. So a direct plug-in would have given us infinity over infinity, but notice we're canceling out that issue, the infinity over infinity. And then when we plug in, we get 2 plus 4 over infinity, very close to 0, minus 1 over infinity. And on the bottom, we get 3 plus 0, which is 2/3. So the thing that I want you to get out of this is that at infinity, the highest power is all that matters, top and bottom. Let's do 3 quick examples. Let's look at the limit as x goes to infinity of 4x squared minus 6x plus 3 all over 1 minus x minus 5x squared. Notice that all that really matters at infinity are the highest powers top and bottom, along with their coefficients, of course. So I could do the following. I could basically ignore the things that aren't the highest powers top and bottom and just end up with this. If I plug in, I get infinity over infinity. I already know my x squareds will cancel, and we get negative 4 over 5. Now, when you're doing these problems, hopefully you can just look at them and get the answer. That is, if you were taking my test, I would not require anything more than just an answer. But if you need to go through the process, that's perfectly fine as well. Let's take a look at this new one. Limit as x goes to infinity of x cubed plus 2x minus 3 over x squared plus x minus 1. Highest powers are all that matter, top and bottom. So I could do this, x cubed over x squared. It's a good way of doing it. My students sometimes do it another way, which I'll let you figure out. But if I plug in, I of course get infinity over infinity. But I could simplify x cubed over x squared to equal x. And if I plug in, that gives me infinity. Now, I already knew that by looking. Let me show you real quick what my students like to do, which I allow because it makes sense and it's correct. They like to say, well, the highest power on top is 1x cubed. And the highest power on the bottom, even though it's x squared, I want to match it. So they go, well, let's put 0x cubed on the bottom. And they get 1 over 0, which goes to infinity. Now, there's a little bit of a problem with that, in that if I had 1 over 0 from the negative side, that would go to a negative infinity. But I will talk about that in the next video, which will be pretty short. So let's take a look at one final problem. The limit as x goes to infinity of 2x squared plus 5 over 4x to the 4th minus 3x cubed plus x. I'm going to do the thing where I take the highest powers top and bottom along with their coefficients. But guys, I know that a direct plug-in gives us infinity over infinity. And I will do the 2x squared over 4x to the 4th. And I will simplify this expression down to 1 over 2x squared. And then when we plug in, we get 1 over infinity, which is really, really close to 0.